looking into arteries in a little more detail, we need to look at the different categories and types of arteries. We'll start with the elastic arteries, known as the conducting arteries. Now, these ones think about the aorta and the major branches coming off. So we're talking the ones just after the heart, just after that left ventricle, which means they've got a lot of pressure coming out of the heart. These are some of the largest arteries in the body. They're going to be very thick-walled. They're going to have elastin in all three tunics. Reason being is these vessels are pressure reservoirs. What that means is, as the left ventricle is going to pump the blood out into the aorta, that aorta is going to stretch out a little bit and then slowly come back to size. It's going to fluctuate with every single heartbeat. Every single heartbeat, that our aorta is going to increase in size and decrease. So it's helping to maintain pressure throughout your entire system. Because once the ventricle finishes pumping the blood out, the aorta can still get a little bit smaller to help maintain that pressure, hence the pressure reservoir. So it's that recoil after the blood is done being pumped, that recoil is smaller, that helps to maintain pressure. Now, they also have very low resistance. Because of how large their lumen is, most of the blood traveling through here isn't even touching the wall. Think about a garden hose and a fire hose. Garden hose, sure, the water comes out pretty well, but the fire hose has a whole lot higher pressure and a lot more water is coming out the middle that's not even touching the edges. Lower resistance. Now, lower resistance can be important, and sometimes higher resistance is important in the system. But when you're first coming out of the heart, you want as low of resistance as possible, because that blood's got to get to everywhere else in the body. So here are what you're looking at for the elastic arteries. You'll notice the tunica externa is pretty thin. Remember, tunica externa was a lot of collagen fibers. So if you want the vessel to be opening and closing a lot, do you want a lot of very stiff, strong collagen? Not really. Instead, the tunica media has a lot of smooth muscle, but also a lot of elastin fibers. So a lot of stretch and control here. And then, of course, you have the tunica intima, which also contains some elastic fibers. So that's your elastic artery. Once you go past the elastic arteries and head away going into the body, so past the aorta, you're getting past the major vessels coming off, now you're into these distributing arteries. They're distal to the elastic arteries, so further away from the heart. Their purpose is to get the blood to the organs. So go down to the stomach or the liver or the pancreas or the biceps brachii or wherever. It's getting the blood out to the different organ systems. Their tunica media is pretty thick and filled with smooth muscle. Because again, that smooth muscle can constrict, helping to maintain blood pressure, that vasoconstriction. So it's really active in the vasoconstriction, the maintenance of blood pressure. Because you have to have enough blood pressure to get to the tissues. So notice here, the tunica externa is now a little bit thicker, a little bit larger. So you have a little more collagen located in these ones. The tunica media is still a decent size, but there's not going to be as much elastin. There's still elastin, just not as much as the elastic arteries. So this is your muscular artery. And then you get down to the arterioles. The arterioles are the smallest of the arteries. These are meant to really slow down your blood flow, lower the pressure of your blood. Their main goal is to protect the capillaries that come after them. So by increasing the resistance, you're slowing the blood before it hits these capillary beds. That's the key thing. So more resistance on the blood flow means that slows down because it's kind of bouncing off the walls, hitting more things. So as these arterioles get smaller and smaller and smaller, there's more and more resistance to slow your blood flow down. Now, as you slow the blood heading into the capillary beds, This is all done by vasodilation and vasoconstriction. Before those capillary beds, there's also sphincters that will help to control the flow as well. But you're trying to slow things down to allow the capillaries to be more efficient in exchanging their gases and nutrients and waste products. So if you look at the arterioles, they're smaller. The tunica externa, pretty small. Comparatively, look at the tunica media. Couple cells thick, that's it. So these are much thinner walls, much smaller vessels that are increasing the resistance to slow your blood down. So the arterioles, smallest of the arteries. From the elastic arteries, the biggest, to the muscular arteries heading out to the rest of the body, to the arterioles leading into the capillaries, all looking at the different ways your blood is flowing through the arterial system.